Okay, you learned about how to write and translate and graph inequalities. Today we're going to talk about how to solve inequalities. And before we do that, we'll do a quick refresher of just solving an equation, because solving an inequality is just like solving an equation. So if your inequality looked like this, 3x plus 8 is less than 2, you could solve it just like if it said 3x plus 8 equals 2. There would be no difference, except that instead of an equal sign, you would have a less than sign. So dropping down, normally you would drop down the equal sign, and this time you just drop down the less than sign. So when it says solve, that means get x by itself. So we would have to get rid of 3 and 8. Since 3 is being multiplied by x, we would get rid of it with division. Since 8 is being added to x, we would get rid of it with subtraction. And for solve, we always go in the reverse order of operations. We use PEMDAS. So we're going to subtract, we don't use PEMDAS, we use SADMAP. So we're going to subtract 8 first, and that will give us 3x is less than negative 6. Then we'll divide by 3, and that will give us x is less than negative 2. So that would be your solved inequality. And that means that any number less than negative 2 is a solution to this inequality. So if you pick a number less than negative 2, for example, negative 10, you should be able to plug negative 10 in for x in your original equation or inequality. And when you simplify the left-hand side, it would make this inequality true. So if you simplified 3 times negative 10, that would be negative 30. Negative 30 plus 8, that's negative 22. And that's definitely less than 2, so that works. The only difference, there is one little difference when you solve inequalities that's different from when you solve equations. And that is that if you, at any point in the inequality, in the solving process, if you multiply or divide by a negative number, then you have to flip the inequality. And by flip, I mean turn greater than into less than, turn less than into greater than. So there are 4 one-step inequalities on your guided notes sheet. I want you to solve each one of those and see if you can figure out when to flip the inequality and when not to. The first one is 5x is greater than 25, greater than or equal to 25. So to solve this, we would divide both sides by 5. And since we're dividing by 5, not a negative number, we do not need to flip the inequality. So your answer would be x is greater than or equal to 5. On this one, to get x by itself, we would have to divide by negative 1, since we will want to get rid of the negative sign. And since we are dividing by negative 1, we would have to flip the inequality. So the answer would say x is greater than negative 17. Here, x over 3 is greater than 5. We want to get rid of the 3, so we have to multiply by 3. We're multiplying by a positive number, positive 3, so we do not need to flip. So that's going to result in x is greater than 15. And this last one, we want to get rid of negative 6. So we'll multiply by negative 6, multiplying by a negative. We will have to flip the inequality. So the answer should say x is greater than or equal to negative 24. Now, most of the examples that you'll work through in your practice will be a little bit more complex, not just a simple one-step inequality, but anytime you get to a step like one of these, where you have to multiply or divide by a negative number, at that point, turn the inequality symbol around. And you'll be all set. That's the only difference.